In this video, we're going to work through the first half of Unit 4 review. Question number 1, which best describes the type of triangle? So an acute triangle is going to have all acute angles. An equal angular has all angles measuring the same. An obtuse triangle has one angle that's greater than 90. And a right triangle, of course, means you have a 90-degree angle. In this triangle, we can see that this angle at the top is going to be greater than 90. This is an obtuse triangle. In problem number 2, what is the length of AC if it is equilateral? Well, if it is equilateral, that means all the sides are the same length. We can take two of these sides and set them equal and solve for x. So I'm going to go ahead and avoid the decimals and just work with the two sides that have integer lengths. All right, so here we go. Let's subtract 6x both sides and add 5 to both sides. And so we get 8 is equal to 4x. If I divide both sides by 4, I get that my x value is 2. That's not answering the question, though. I want to find the length of AC. If I plug in 2 for my x value, that's going to give me 20 minus 5, which is 15. That's my answer. In problem number 3, it wants us to use the figure, and it's asking for the measure of angle 2. All right, so let's see. By vertical angles, I can see that angle 1 is going to be 60 degrees. And the sum of the three angles in a triangle is 180. So 70 and 60 make 130. That means angle 2 must be 50 because 180 minus 130 is 50. Now, what's the measure of angle 4? Well, angle 4 is the exterior angle. And according to the exterior angle theorem, it is the sum of the two angles inside that are not adjacent. And so 60 and 40 make 100. Now, we could have also solved for angle 3 by adding 60 and 40, getting 100, and then angle 3 then would be, well, 80. Since 3 and 4 make a linear pair, 180 minus 80 gives you 100. So there's other ways to solve for these angles. And number 5, which triangles are congruent in the figure? Well, let's match up the sides. We have side AB is congruent to side CB, and, well, actually, we can just probably look. AE is congruent to CD. So I'm looking at triangle ABE is congruent. ABE is congruent to CBD. And so ABE, CBD, ABE. Here, how about this one? Make sure the letters are in the right order, and that would be the answer. In number 6, in the figure below, we have two triangles congruent. What is the measure of angle IJK? So IJK, I'm looking for this angle over here. Well, I can see that the measure of angle G is going to be congruent to the measure of angle K. And so this guy is 30. If I add the 50 and 30, that gives me 80. And 180 minus 80 gives me 100. So angle J is 100. In number 7, a triangular-shaped roof of a house has congruent legs. That means these guys are congruent. What is the measure of each of the two base angles? Well, this gives us an isosceles triangle. Base angles are congruent. And so if I take 180 minus 80, that gives me 100 degrees to split between the two base angles. So each base angle is going to give me 50 degrees. All right, we have a proof for numbers 8 and 9. It says given L is the midpoint of JM. That means each of these pieces here is going to be the same. So I'm going to mark some congruency marks. L is the midpoint, so L is exactly in the middle. JK is parallel to NM. Okay, so that's what we're looking at here. JK is parallel to NM. That's also given. I'm going to mark one other thing. I don't know if I need it or not, but I've got vertical angles. All right, so here's my proof. It says L is the midpoint, that's given. JL is congruent to LM, and that's definition of a midpoint. We have our given statement that the two JK and NM are parallel. JKL, this angle, is congruent to MNL, so let's mark it. And that's telling us by alternate interior angles are congruent. So JKL, this angle here, is congruent to MNL. These are our alternate interior angles. Okay, so then we've got the next statement, JLK is congruent to MLN. Well, we've already said that that is because these are vertical angles. So that would be C. So we've got, let's take a look what we've got. We've got a side angle, angle. Angle, angle, side. What do you think? That is a congruency theorem. And so if we can prove these two triangles are congruent, it can be by angle, angle, side. Angle, angle, side. And so that's what I'm going to go with, angle, angle, side. And number 10, if triangle LMN is isosceles, that means these are congruent sides. T is the midpoint of LN, so I've got congruent pieces here. And by the reflexive property, MT is congruent to itself, I'm going to go with, well, which postulate can be used to prove triangle MLT is congruent to MNT? Well, I think something's missing. Angle, angle, angle is not a congruency theorem. ABC is not a congruency theorem either. So I'm thinking that that's supposed to say side, side, side. And I can use that to prove they're congruent. In number 11, it says if MLT is congruent to MNT, what is used to prove angle 1 is congruent to angle 2? Well, corresponding parts of congruent triangles are congruent. If we can prove the two triangles are congruent, then all their parts are as well. 12 through 16, match the theorem with the correct pair of congruent triangles. Okay, so in number 12, I see that all three sides are congruent to all three sides, and so that's D. I've got a side, an included angle, and a side, so that's side, angle, side, that's B. In number 14, I have an angle, then another angle, and a side. So that is angle, angle, side. In 15, angle, side, angle. And so that's letter A. And in the last one, this is a right triangle. So we've got a hypotenuse and a leg. And so I'm going to use choice C for that last one. Whoops, sorry about that. All right, number 17, if triangle CJW is congruent to AGS, the measure of angle A is 50, so that means this guy is going to be 50 also. Measure of angle J is 45, so that means G is going to be 45 also. Measure of angle S is equal to 16x plus 5. What is the measure of angle? What is the value of x? Well, if I add these two together, 45 and 50, that gives me 95. 95 degrees, I don't know why I put the degree symbol on that side, that's weird. Okay, so 180 minus 95, let's see, what should that add up to? Let's see, I'm going to subtract 5, and then this gives me 85. So I know that this base angle right here, this guy is going to equal 85. If I subtract 5 from both sides, that'll give me 80. And let's see, what's 80 divided by 16? I'm going to grab my calculator real quick. 80 divided by 16, and x is equal to 5. All right, let's see. I think that's all I'm going to